Welcome back, friends. Today I am back again with a new kind of limit problem. As you people can see, I have already written the problem in the screen. So now I would like to request you people pause the video and give yourself a chance and then came back to see the solution. So now let's begin by how we can solve this kind of limit problem. When we learn limit and its calculation, its formulas, there is a very useful result what we learn when we learn limits, and this very useful result is so-called sandwich theorem or squeeze theorem. So I will write it for you people. See, sandwich theorem. Suppose there are three functions. One is f, one is g, and the other one is h. And the relation between them is something like this. Now, if we take limits on both functions, and it is always true that the functions have always the same domain, obviously, and if we calculate the value of those limits at the same point like this, then what will be the value of this limit? We have to know the value of this limit, and we are given that then this relation. Now if limit x tends to a, f is equals to say L, and it is equals to limit x tends to a h, that is this left hand limit and this right hand limit, these two limits are equal, then what will be the middle person? Then the limit of the middle function, the middle person, it will also be the same. This is called L, and this is called sandwich because these parts and these parts in between these two functions, this function simply becomes the sandwich. That's why the name is sandwich or squeeze theorem. Now in our problem, as we people can see, the function is 3x plus 3 to the power x plus 4 to the power x whole to the power 1 by x. We can write it say like this: fx equals to 3 to the power x plus 4 to the power x. Now what we can do, we can write it like this. Sorry, there must be 1 x. We can write this like this. See, we just take common 4 to the power x. If we take common 4 to the power x, then it will become simply 3 by 4 whole to the power x, and 4 to the power x power, it will cancel out, simply becomes 4. So we can say that this result will always greater than 4 because this thing, it is always greater than 1, right? So this is a relation, and again we can do one another thing. That another thing can be like this, say 3 to the power x, it is always less than 4 to the power x in any cases. Now if we add 4 to the power x in both sides, what do we have? We simply have 2 4 to the power x. This is 2 into 4 to the power x. Right? We simply adding 4 to the power x in both sides. Now if we take the power as required, that is 1 by x, then we will have something like this: 2 into 4 to the power x, and this power by 1 by x. Right? Agree? And this will become something like 2 to the power 1 by x, 4. This thing will definitely be greater than 0, greater than 1. So we can write that our fx will always be less than equals to 4 to the power. There is a problem you people can ask, and that problem is, what will be the role of this 2 to the power 1 by x? Okay, then just keep it here. If we keep it here, then we can write it like this. Like put it like this. Then from 1 and 2 we can write it that, see, fx sometimes greater than equals to 4, sometimes it less equals to 4. So we find that simply 4 less equals to fx less equals to 2 to the power 1 by x into 4. Now, as I have stated above in the given sandwich theorem, we have to simply calculate the limit of this thing. Now, what will be this limit? If you calculate this limit, see, x tends to infinity. So what will be this limit? This limit will be 1. You people may wonder why it is 1. It follows like this. Say, when limit x tends to infinity, 1 by x tends to always 0, right? 1 by, so big large number always tends to 0. And what is 2 to the power 0? 2 to the power 0 is 1. That is why this limit is 1. If this limit is 1, then our problem becomes something like 4 less equals to limit x tends to infinity fx, and it will again less equals to 4. So by sandwich theorem or by squeeze theorem, we can say that the required limit is 4, like this. If you people find this video useful, then please do support us.